Hello. Today we're going to make this cool little exponents book right here. And we're going to write down lots of different rules and be using this unit. So you need a piece of blue paper. You need a pair of scissors. And I also have some directions on paper. So if you want, excuse me, if you would like to have the paper directions, I left a pile for the sub, but I'm going to, in the video, do everything on these directions. So it's kind of up to you. You can maybe have both, and if you want to pause the video and follow the paper directions, you could do that. Okay, so you might pause the video until you have everything you need. So we're going to take our paper, and you are going to start out by folding it hot dog style. So as you fold, make sure you have everything all lined up before you start creasing. It'll just make it all look a little nicer in the end. Okay, so you have this folded hot dog style, right? So you're going to fold it in half now the other direction twice. So pretty much what I did was I have it sitting on my desk like this, and I folded it the bottom up to the top. So you want to get it all lined up and crease it in half, and then fold it in half one more time. So now I have this little rectangle, and actually I want to open it back up. And when I do that, you should see 8 sections on your paper with the folds. Okay, so let's open it back up. So you've got 8 sections here. Now you're going to take it and fold it hamburger style. So I'm going to fold it in half like this, and you'll be folding along one of your creases. So fold it along that crease. Now my fold is at the top right here, because at the bottom is where I can lift it up. Now I'm going to take my scissors and cut from the fold down to the center. Okay, so I've got the folded edge, and I'm going to cut from the fold down to the center. So now it kind of looks like this. This is the folded region. Okay, so I'm going to open it back up, and now you have those 8 sections again with this middle section cut out. So fold it hot dog style again. So go back to our original hot dog style fold, and I want you to pick it up. And when you look down at it, can you see the opening there? So what we want to do is continue to push it together so that that opening ends up looking like it does there, and just keep flattening it out until I guess you match up the two ends. Okay, so let me go back. I had it like this. I took it and I opened and kept pushing until it was folded over on top of itself. Okay, and then I'm going to take the right hand side and fold it over to the left and just recrease along one of those folds. So when you do that, if you turn it back over like a book so that the spine is on the left, you should be able to open it like a reading book. So there's the first 2 pages, there's 3 and 4, 5 and 6, and then there's the end. Okay? So this is our booklet that we are going to write a lot of our exponent rules in. And let's make sure you get something to write with. I'm going to grab a couple pieces of paper because it looks like there's a glare on the screen. That might help there. Actually, I think I'm going to take the back of this one, do it on white, and it's white paper. Okay, so grab yourself something to write with if you want to get some different colors, if you want to just get pencil or pen, that's up to you. I'm going to kind of decorate mine as I go. But I'm going to call this Mrs. Sharp's Book of Exponent Rules. So you can name it, of course, with your own name. So that's all we're going to have on the first page is a title, and I'm going to have a couple examples. So Mrs. Sharp's Book of Exponent Rules. Of course, I wouldn't call yours Mrs. Sharp's. I would call it by your name. And I'm just going to add a couple of little decorations here. Okay, so I'm also going to then just put some examples of some exponents. So x squared would be something we might see, maybe 3 to the 0 power. We might also see something like that looks like this in parentheses, xy to the 3rd power. All right, so go ahead and finish up your cover. These are going to be your exponent rules. And as I go through this video, definitely pause it to catch up. If I waited the entire time, it would be a really long video. So feel free to pause it. So go ahead and open it up to the next page. And I'm going to have in here some vocabulary. So I'm going to put sort of a divider down the center because I'm going to have some things on either side. Okay, so the first thing I'm going to title over here at the top, I'm going to write down parts of a power. Parts of a power. So what I want to do is write down or identify different sections for you. So I'm going to just give an example of, let's just write down 4 to the third power. So 4 to the third power is the same as 4 times 4 times 4. Okay, now remember, 4 to the third is not 4 times 3. So 4 times 4 is 16, and 16 times 4 is 64. So there's a few elements in here I want to label. The 4 right here, the number 4 is called the base. So I'm going to draw an arrow over here, and I'm going to write the word base. So the big number 4 is considered the base. The small number 3, we call that the exponent. The exponent. So every problem like this has a base and an exponent. And then the other thing is when we look at all of it together, the problem of 4 to the third, I'm going to kind of go like that. A lot of times that's referred to as a power. So the problem in total is called a power, whereas the 4 itself is the base, the 3 is considered the exponent. So let's write now down here below that really what that exponent is. So the exponent tells us how many times the base is multiplied together. So let's jot that down. The exponent tells us how many times the base is multiplied together. The exponent tells us how many times the base is multiplied together. So it does not say multiply those numbers together. It's how many times it's multiplied together. Okay, so one other thing I want to address on the right-hand side is dealing with something to the first power. So if I just have a number, let's just say 2, that is equal to 2 to the first power. So any number, 2 or 10, or even any variable, x or y, when there's no exponent shown, it's always this implied number 1. So let's write about that below there. So if a constant or a variable does not have a written exponent, it is automatically an exponent of 1. If a constant, and a constant is just a number, if a constant or variable does not have a written exponent, if a constant or variable does not have a written exponent, it is automatically an exponent of 1. It is automatically an exponent of 1. Okay, so this is a very important concept. I often find that students get confused by that. So let me give you another example with variables. we could say if I gave you like x times y to the third times z, that is the same as x to the first, y to the third, and then z to the first. Alrighty, let's move on to the next couple pages where we're going to actually look at our zero and negative, our first section, which is zero and negative exponents. Okay, so let's go ahead and turn. I'm going to separate again here. So our first topic today are zero exponents and negative exponents. So actually I'm going to start over here with negative exponents. So let me title this side, negative exponents. Now, when we work with negative exponents, I'm going to define that for you in a little bit, but we don't like to end our problem with negative exponents, and we want to simplify it, kind of like when we have a fraction, we like to reduce it. So I'm going to give you a couple of tips to do that. So the first thing I'm going to write here is to turn a negative exponent into a positive exponent. To turn a negative exponent into a positive exponent, we're going to cross the line and change the sign of the exponent. I'm actually going to switch colors here because this is going to be the important part to remember. We are going to cross the line and change the sign. And change the sign. Cross the line and change the sign of the exponent. So kind of got a rhyme to it, so you can try to remember that. Cross the line and change the sign. So here's an example problem. Let's say I give you x to the negative second power over y to the negative third. So whenever I see negatives, I'm basically going to cross the line. I'm going to cross the fraction bar and change the sign. So what that means is I'm going to take the x to the negative 2 in order to make it positive. I'm going to cross the line and put it on the bottom. And when I cross the line, it makes the negative 2 turn positive. Same thing on the y. If it starts on the bottom, to make it positive, I cross the line to the top and it turns positive. Okay, and so we'll practice that a little bit more, and I've got a few more examples to show you. So let's also address, before we go on, a zero exponent. So I'm going to give you a couple of examples. If we were trying to simplify x to the 0 power, or even 1,000 to the 0 power, 0 powers are easy because the answer to anything to the 0 power is always 1. So x to the 0 power is 1. 1,000 to the 0 power is 1. And I'll explain that here in our notes in just a minute. So let's make a comment here. Anything raised to the 0 power equals 1. Anything raised to the 0 power is equal to 1. I'm going to make 1 really, really big because that is going to be something really important to remember. Is equal to 1. Anything to the 0 power is equal to 1. Key element here. Anything to the 0 power is equal to 1. I'm going to put a big circle around that. Anything. It can be numbers. It can be variables. Let me give you a crazy example. Let me give you an example of, in parentheses, x times y to the third times z to the second, close your parentheses, all of that goes to the 0 power. It equals 1. So these are the two things we're going to practice today. So make sure you have your book with you, and we need to switch over to our new note packet.